The darkness between the stars is not empty. It is a vast, cold ocean, and occasionally it sends us messages. These are not signals, but physical relics. They are voyagers from other suns, carrying the chemical secrets of their birth. We have just found another one, but this one is already challenging everything we thought we knew. This object is not just a visitor. It's a scientific anomaly of the highest order. Now let's access the field logs and analyze the true nature of this incredible visitor. The object cataloged as 3I/Atlas is only the third interstellar visitor ever confirmed in human history. And in the 4 short months since its discovery, it has already generated a frenzy of observation and debate. We've seen nearly 100 papers submitted to astronomical journals, a rate of research that is almost unprecedented. Everyone wants to understand this object before it vanishes back into the void. Open bracket B, REATH, close bracket. A pause. But there is a problem. The moment of its greatest scientific potential is happening right now. On October 29, 2025, 3I/Atlas reached perihelion. This is its closest approach to our sun, the point of maximum heating. It is a fiery crucible, plunging to within 1.4 astronomical units of the sun, that's closer than the orbit of Mars, asterisk. This intense solar radiation is the engine of its activity. We expect its icy nucleus to be sublimating violently. This process, turning solid ice directly into gas, is what builds a comet's coma and tail. It is in this gaseous envelope, this coma, that the comet's primordial chemical fingerprint is revealed. Open bracket BREATH, close bracket. A moment. What is it made of? What materials did it carry from its home star? Is it like our comets, or something fundamentally alien? These are the questions that define this encounter. And for now, we are completely blind to the answers. The geometry of this encounter is a kind of cosmic cruelty. From our vantage point on Earth, 3I/Atlas is currently lost in the blinding glare of the sun. We cannot get a clear spectrum. We cannot measure the composition of its outgassing at the very moment it is most active. Asterisk. This proximity to the sun effectively shields its secrets from our most powerful telescopes. We are forced to wait, tracking its path with orbital mechanics alone. We must wait until early December, when it emerges from the glare, by which time this peak activity will have subsided. Open bracket BREATH, close bracket. A breath. So what do we know? We know it is on a path that can only have come from outside. To understand what it is, we must first analyze how it got here. We must trace its journey from an unknown star. Its story, as far as we are concerned, began in July of 2025. It was first flagged by the Asteroid Terrestrial Impact Last Alert System. This is ATLAS, a network of robotic telescopes in Hawaii, Chile, and South Africa. Its primary mission is to scan the entire sky every night, searching for potential threats. But this object was not a threat to Earth. It was a profound challenge to our understanding of the galaxy. Initially, it was just another faint point of light, another minor body designation. But as observatories around the world began to track it, they fed its position into orbital models. And a number emerged from those calculations that did not make sense. That number was its velocity. Open bracket BREATH, close bracket. A critical measurement. It was moving too fast. Not just fast, but impossibly fast for anything that belongs to our solar system. As we refined the measurements, its speed clocked in at a staggering 58 kilometers per second. That's over 130,000 miles per hour. To put that in perspective, Mercury, our fastest planet, orbits the Sun at an average of 48 kilometers per second. Asterisk. This object, deep in space, was already moving faster than our innermost world. This speed is not a simple detail. In celestial mechanics, speed is destiny. It determines your entire path. Everything that belongs to our solar system, whether it's a planet, an asteroid, or a comet from the distant Oort cloud, is gravitationally bound. It travels on a closed elliptical orbit. It is on a cosmic leash. No matter how far it swings out, the Sun's gravity will always eventually pull it back. But 3I/Atlas has broken that leash. In truth, it was never on one. Open bracket BREATH close bracket. A pause. Its incredible velocity places it on a very specific open-ended path. This is known as a hyperbolic orbit. It is not a loop, it is a flyby. The Sun's gravity is simply too weak to capture an object moving this fast. It can bend its path, but it cannot close the loop. Asterisk. This is the smoking gun. This is the irrefutable, mathematical proof that 3I/Atlas does not come from our solar system. It was born in the icy disk of another star, countless light years away. It has traveled for millions, perhaps even billions, of years through the interstellar deep. And now, by pure chance, its trajectory has brought it on a brief, fleeting journey through our front yard. Open bracket BREATH close bracket. A moment to consider. This changes the context. It is not just a comet, it is an artifact. It is a probe, built by nature, carrying a pristine sample of a distant stellar nursery. This confirmation transforms our curiosity into an urgent scientific imperative. We are no longer just observing a rock, we are intercepting a message. But as we began to compare this new messenger to the ones that came before, the story took another sharp turn. This visitor wasn't just fast, it was different. We have had interstellar visitors before, but only two. 1I/Oumuamua in 2017, and 2I/Borisov in 2019. They provided our first ever glimpse into the material from other stars. Oumuamua was a bizarre, tumbling, rocky cigar. Borisov looked much like one of our own comets. They set our expectations. 3I/Atlas has completely shattered them. Let's start with scale. Oumuamua was small, perhaps a few hundred meters long. 2I/Borisov was larger, maybe a kilometer wide. Our preliminary estimates for 3I/Atlas, based on its brightness, are staggering. This object is a giant, estimated to be up to 5.6 kilometers, or 3.5 miles wide. It is a true interstellar mountain, dwarfing its predecessors. Then there is the speed. We clocked Borisov at 32 kilometers per second and Oumuamua at 26 kilometers per second. Atlas is nearly double that at 58 kilometers per second. Asterisk, it is bigger, it is faster, and it suggests the population of these objects is far more robust than we dared to imagine. Open bracket BREATH close bracket. But size and speed are simple metrics. The true weirdness, the part that has orbital dynamicists baffled, is not its speed, but its direction. Our solar system is not a 3D space of random orbits. It is a remarkably flat system. The planets all orbit the Sun on a thin shared plane, almost like marbles rolling in the same groove on a record. We call this the ecliptic. Asterisk. Now picture the galaxy. Stars are scattered everywhere, above us, Below us, in all directions. An interstellar visitor ejected from a random star should arrive from a random angle. And that is exactly what we saw before. Oumuamua plunged in at a steep 123-degree angle to our ecliptic plane. 2I/Borisov came screaming down from above at an angle of 44 degrees. They cut through our solar system, completely ignoring the plane of the planets. This makes perfect sense. There is no reason for them to align with our local orientation. Open bracket BREATH, close bracket. Until now. Atlas is the exception. It is not diving in from above or rising from below. It is approaching us almost perfectly within the ecliptic plane. Its orbital inclination is a mere 3 degrees. It is flying straight into our solar system on the same level as all our planets. It is the cosmic equivalent of a T-bone collision, asterisk. The odds of this are almost impossibly low. It implies that it was ejected from its home star on the exact same plane that our own solar system occupies. How is this possible? Is it a coincidence? Is it just a 1 in a billion chance alignment? Or does this hint at something profound? Does it suggest some shared alignment in the local stellar neighborhood? Some filament of the galaxy's structure? We don't have an answer, but the alignment is deeply unsettling. This trajectory is the first great mystery of 3I/Atlas, but as we began to get our first, precious readings of its composition, we found this was only the beginning. The real shock lay in its chemistry. This impossible trajectory was just the first hint that 3I/Atlas was special. As we dug deeper into its origins, the puzzle only intensified. By tracing its hyperbolic path backward, out into the galaxy, we can estimate its origin. Its path doesn't originate in the thin disk of the galaxy, the spiral arms, where our sun resides. The calculations point to an origin in the thick disk. This is a more ancient, more diffuse, and more chaotic population of stars that surrounds the thinner plane. Based on this trajectory, its estimated age is a staggering 7.6 billion years, meaning it was born before our own sun and Earth even existed. Asterisk. It is not just a visitor. It is a pristine fossil from the galaxy's adolescence. Open bracket BREATH, close bracket. A relic from an older time. And it behaves like nothing we know. Our first major clue came from the TESS satellite, which monitored it as it approached. TESS measures flux, the total brightness of an object. As Atlas got closer, its flux began to spike, but far more violently than expected. The data showed its brightness increased 5 times more than any of our standard cometary models could predict. This wasn't a stable, gentle sublimation. This was a sign of massive, unstable activity. But of what? It wasn't water. The real shock came when we got our first chemical spectra. 3I/Atlas began outgassing early, way out at 5 astronomical units, near the orbit of Jupiter. At that distance, it's far too cold for water ice to turn to gas. The gas we detected was overwhelmingly carbon dioxide. We found it had a CO2 to water ratio of 8:1. Asterisk. This is the complete opposite of comets from our own solar system. Our comets are dirty snowballs, heavily dominated by water. This object is a dirty, dry ice ball, suggesting it formed in an incredibly carbon-rich environment, a stellar nursery profoundly different from our own. Open bracket BREATH, close bracket. A different kind of solar system. This carbon-rich nature even explained another bizarre, early observation: its tail. For a short time, 3I/Atlas was observed with a tail that appeared to be pointing towards the sun. This, of course, is physically impossible. It was an anti-tail, a well-known but rare optical illusion caused by large, slow-moving dust particles left in the comet's orbit. This CO2-driven engine was blasting out heavy grains, creating a spectacular but misleading sight. Then, its chemistry shifted. As it crossed Mars's orbit and heated up, we detected a sudden, massive surge in water vapor. It was as if a new, water-rich layer of the comet had suddenly been exposed and vaporized. And then, the metals appeared. First, our spectrographs showed a clear signature of nickel, but strangely, no iron. A week later, a strong signal for iron suddenly flared up. This isn't a homogeneous object. It suggests a complex, layered, or lumpy interior, where different materials sublimate in sequence. It's chemically stratified. Asterisk. Open bracket B, REATH, close bracket. But the strangest clue was last. It came from its light. When we study the sunlight that scatters off a comet's dusty coma, we can measure its polarization. This tells us about the physical structure and size of the dust grains themselves. And the data from 3I/Atlas was, again, impossible. This object exhibits the most extreme negative light polarization ever detected. Not just in a comet, in any solar system body ever, asterisk. It doesn't just bend the light strangely, it breaks our scale of measurement. This tells us the dust grains in its coma have a physical structure or composition that is fundamentally alien to us. We have no models to explain it. It is an ancient, layered, carbon-rich giant on an impossible path, made of dust we've never seen. And it was about to fly right past our robotic emissary at Mars. This bizarre, ancient object was not just a target for distant telescopes. Its impossible ecliptic trajectory, that T-bone alignment, sent it on a collision course with our robotic exploration network. On October 3, 2025, just before it vanished into the sun's glare, 3I/Atlas had its first close encounter. It passed just 0.19 astronomical units from the planet Mars. Open bracket B, REATH, close bracket. A cosmic flyby. We were there to see it. This was an unprecedented stroke of luck. The Perseverance rover, from its vantage point in Jezero Crater, turned its Mastcam-Z skyward. It captured the first ever ground-based images of an interstellar object from another world. Simultaneously, the ExoMars Trace gas orbiter, in orbit above the rover, trained its instruments on the comet's coma as it swept past. Asterisk. We were able to sniff its chemical composition from close range, just as its water and metal signatures were flaring up. While we are still awaiting the high-resolution images from the Mars Reconnaissance Orbiter, the data we have already is invaluable. But this was just a preview of the main event. Now it comes for us. As it pulls away from the sun, its trajectory will bring it near our own planet. On December 19, 2025, 3I/Atlas will make its closest approach to Earth. It will pass us at a safe distance of 1 astronomical unit, about the same distance as the sun. It will be a prime target, finally free of the sun's glare, for every major observatory on the planet, including the Webb Space Telescope. This will be our best window to solve the riddle of its polarization, its layered chemistry, and its ancient origins. But it is not our last. Open bracket B, REATH, close bracket. One final chance. The comet's path carries it outward on a trajectory that will give it one final close encounter, a pass by the king of our solar system, asterisk. On March 16th, 2026, 3I/Atlas will fly just 0.36 astronomical units from Jupiter. And we have another emissary waiting there, the Juno spacecraft. Juno's primary mission is to study Jupiter's magnetosphere, but this is an opportunity that cannot be missed. Its instruments will get a final, precious look at this visitor before it leaves us forever. After that, it will fall silent. It will drift back into the cold, its ices refreezing, its secrets locked away once more. It will return to the interstellar ocean, continuing its journey for millions of more years. Open bracket BREATH close bracket. A long, reflective pause. This ultimate weirdo has served as a profound and humbling messenger. It has shown us, in the most direct way possible, that the galaxy is infinitely more diverse than our small neighborhood would suggest. Its impossible trajectory, its alien chemistry, and its physics-defying light tell us that other solar systems are not just different. They are truly alien. 3I/Atlas is a single data point, but it has forced us to throw out the entire book of what we thought was normal and begin again.